Assalamu alaikum students. So today we're gonna study the VESPR theory, and basically we have to form the structures that comes into the VESPR theory. So the first form of the VESPR theory is the AB2 structures. So in AB2 type we have an example of BeCl2, beryllium chloride. So Be referred to as the beryllium and Cl2 referred as the chloride. So for that structure, for the formation of that structure, we have to find out number of lone pairs and the number of bond pair present in the BeCl2 molecule. So the number of lone pair in BeCl2 is 0. So on the number of bond pair is 2. Let's find out the electronic configuration in beryllium, which is the Be, and the atomic number is 4. So the electronic configuration for beryllium is 1s2 and 2s2. 1, 2, 3, 4. So our 4 number is fully satisfied with these two subshell. Let's come to the excited state of the beryllium. So for the excited state we have to put one electron in each subshell orbit. So for 1s2 we have to completely fill the 2 here for the 1s2 subshell, and for the 1s2 for the 2s2 we have other 3 subshells, which is 2s1, 2px, 2py and 2pz. So we have to shift our one electron from 2s2 to 2px. So we have now 3 subshells, 1s2, 2s and 1, and the 2px1. Basically we just do the thing, which is we have to fill s shell, we have the 1 shell and the 2s, and then we have the 2p shell, or we have again 3s shell. So we have to fill that things first. So the first orbit has 2 electrons in it, so we have to fill 2 in it. So 1s has the 2 electrons. Then comes to the s2 orbit, which also have the 2 electrons. We just put the 2s, 2 electrons, 2 here and 2 here. It is the normal condition. When we talk about the excited state, we have to shift one electron from the 2s to the here 2p. So the question arises, why we cannot shift one electron from here to there? So the answer for that question is, like 1s2 is completely a single orbit, and for the 2s case it is not complete orbit. The complete orbit is this. So that thing is attached with each other. This is a separate thing and this is also the separate thing. So we have to shift one electron from here to the neighboring electrons, and for that case we have the 2p orbit, which is divided again into the 2px, 2py and 2pz subshells. So we have divided that 2p into the 3 shells. Here is a case that we have we can fill the 2 orbits here, we can fill 2 electrons here in each subshell. So the total is 2, 2, 4, 6, 7, 8, 7, 8 and then 2. We have filled the 10 electrons here. So the 2s has the 2 electrons in its normal condition. We will form the excited state, so we have to shift one electron from here to our neighboring electrons. I just divided these 2p into the 3 subshells, which is the 2px, 2py and 2pz. Now I am just trying to shift one electron from 2s to the one of my neighboring electrons. So our excited state will be the 2px, 2py and 2pz with the one shifted electron. So in this way we have our excited state, which is the 1s2, 2s1, 2px, 2py and 2pz, and the one electron from the 2s is shifted toward the 2px. So now it is 1s2, 2s1 2px1. Let's come to the electronic configuration of the chlorine, which is the simplest form. Now we have to fill 1s2, 2s2, 2p6. Now the 3s and the 3p orbit is divided into its subshell, which is the 3s2, 3px, 3py and 3pz. 1, 2, 3, 4, 4 and 6 is equals to 10. So 10 electrons is filled in this case, and we have left over the 7 here. So I have to put 2 electrons into 3s2, and then 2 into the 2px, 2 into the 2py, and akela and the 1 only into the 3pz. So this is the electronic configuration of the chlorine. Let's form the structure of the chlorine. Firstly, we have the Lewis structures, which is beryllium and the chloride. We have to form BeCl2. So beryllium is the only element here, atom here, and we have the 2 atoms of the chlorine. So beryllium will be the placed in the center, and we have the chlorine here, and we just have to place 1 electron of the chlorine and 1 electron of the beryllium, which is this state. 1 electron from the 2s and the 1 electron from the 2px. And for the chlorine case, we have this thing, which is the 7 electron that is present into the outermost shell. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6 and 7. The 7th one will form the bond with the beryllium, and here the 7th one electron will form the bond pair with the beryllium. So total we have 2 bond pairs here in the case of the BeCl2. Let's form the VESPR structure here. So the VESPR structure is the same, but we have to form the angle here. So the angle that is formed between the beryllium and the chloride is 180 angle. So the geometry of the structure is the linear, and the angle of the structure is 180. So this is the complete VESPR theory and the structure of the BeCl2.